In this tutorial, we'll take a look at the remaining parts of the user interface and see how we can use it to explore our known universe. Previously, we explored the Scene panel, the Focus panel, and the Time panel. Now, we continue with the remaining panels contained in the user interface. The first panel we look at in this tutorial is the Session Recording panel, which is represented by a camera icon. A session is a recording of all camera movements and property changes, which can be then played back later. This is really useful if you want to create a video from an interactive flight in OpenSpace. If we open up the panel, we see that it is split into two sections. The top part is used to record a session, and the bottom half is used to play back an already recorded session. To record a session, we pick a file name and press the Record button. Until we press the Stop Recording button, everything we do in OpenSpace, including the camera interactions, changing the focus node, enabling or disabling items in the scene, or changing any property, is captured in this session. To play back a session, we choose the file in the drop-down menu and press the Play button next to it. OpenSpace then plays back the recorded session identically to how it was recorded previously. Specifically worth highlighting is the Output Frames checkbox. If you select this, you can then choose a frame rate. If you then play back a session recording, OpenSpace will make screenshots at the requested frame rate for the entire session recording. You can find the created screenshots in your OpenSpace User Screenshots folder. The next panel is called the GeoLocation panel. OpenSpace comes with a high-resolution map of Earth provided by the company Esri. You can fly down to any place on Earth and OpenSpace will download the terrain and image data for that specific location. Note that this feature requires an active internet connection. For example, let's fly down to Mount Everest to demonstrate the available map data. We approach Mount Everest straight from above, which does not give us a good feeling for the surrounding terrain. However, we can use the same camera interactions that we learned about in the last tutorial and hold the Control key and use the left mouse button. While we were in orbit, we used this to pan the camera. Even as we are now close to the surface, it is still a panning motion, but now it looks more as if we are tilting the camera up from the ground to look along the curvature of our planet. This is also true for the other movement types. The middle mouse button still rotates us around the line connecting the camera to the focus object, but now it feels like looking around the surface of the planet. And Control and middle mouse button simulates the banking movements of an airplane. Flying here required me to know exactly where Mount Everest is located. The GeoLocation panel deals with some of these shortcomings. We can search for locations on Earth and then fly to them automatically. For example, if we want to venture to Mount Nauroy in New Zealand, which served as the filming location for Mount Doom in Lord of the Rings, we simply search for it and use the airplane icon next to it to fly there. As we arrive in New Zealand, we see that it is still night here, so we progress the time forward to bring it in to day. This search feature is also powered by Esri, so make sure to give them a thanks for these awesome features. The next panel on our list is the ScreenSpace renderable panel. ScreenSpace objects are placed in the 2D view of the window rather than living in the 3D scene like the Earth does. While there are many types of ScreenSpace objects, this panel lets you add images that might be useful for a specific presentation. These images might either be URLs on the internet or paths to your own local hard drive. As a first example, we can use a link to an image on Wikipedia. We give the ScreenSpace object a recognizable name and then paste the URL to the image. If we then click on Add, OpenSpace will download the provided image and add it. As a second example, we use an image from my hard drive. We give the new image a different name, and this time we provide a path to any image file that is on my hard drive. Identically to the properties we find in the Scene panel, these objects also have properties that we can manipulate. We can, for example, move the image, scale it, and give it a border color. As mentioned before, there are many more types of ScreenSpace objects that are available, for example playing back videos, showing 3D models, and many more that we will cover in a later tutorial. The next panel we want to look at is our Exoplanet Explorer subsystem. Since the 1990s, we have discovered over 5,000 exoplanets, which are planets orbiting other stars. The exoplanet panel allows us to tap into the NASA Exoplanet Archive data and search for many of the discovered exoplanet systems and add them to the scene. When we open the panel, it is split into two parts. At the top, we have the list of all of the exoplanet systems in the catalog, and at the bottom we see the systems that we have already added. If, for example, we search for Kepler 186, we can then press the blue plus button to add the known contents of that system to the scene in OpenSpace. After a few seconds, the Kepler 186 star now shows up in the list of added systems, and it also has one of these focus buttons. Before we fly to Kepler 186, however, we should leave the Earth and move to a good distance away. Now we can focus on Kepler 186 with the button in the exoplanet panel and zoom towards that star that is almost 600 light years away from us. It's a red dwarf with about half the mass of our Sun. Most of the exoplanets in the catalog were discovered using the transit method, in which a planet moves between us and the host star, so it is not a surprise that we are looking straight at the ecliptic of the system as we approach. When rotating around the star, we can now see the orbit trails of the 5 known exoplanets in this system. We also see the star's habitable zone, which indicates a potential for liquid water on the surface. One planet, Kepler 186f, is on the outer edge of the habitable zone and is in fact the first rocky Earth-like exoplanet found inside of a star's habitable zone. To illustrate the size of the system, we can open the settings menu in the exoplanet panel and enable the 1 AU size ring. AU stands for astronomical unit, which is roughly the distance between Earth and our own Sun. The next panel we look at is called User Panels. This panel allows us to add other web pages into the user interface. At the top of this panel, we can pick any locally saved web page, which we will get back to in a dedicated tutorial. In the middle part of this panel, we can provide the URL to a web page that we want to add as a panel. One resource that is very useful during presentations is, of course, Wikipedia. So let us enter en.wikipedia.org into the URL field and press enter, and voila, we have now a new panel showing Wikipedia. At the bottom of the panel are bookmarks and recently opened URLs, making it easier to navigate the often used web pages. The bookmarks point to 2 other web pages, the Show Composer and the Hub, which will each get their own, more advanced tutorial. For the next panel, we have a look at a new concept in OpenSpace called actions. You can think of actions as a collection of changes that can be triggered through a single button. One of the actions that we can use while we're here at Earth is found in the Trails group and is called Hide All Trails. If we press this button, we see that all of the trails in the solar systems are now fading out. This one click saves us from going into the Scene menu, searching for trail, and then manually clicking every checkbox by hand. Having the trails is quite useful, so we select Show All Trails to bring them back. We can find another useful example in the Constellation Art folder. Here we can pick Show All to display constellation art that was drawn by James Hedberg from the City College of New York. The first time you show the images, it will take a few seconds to load them, but now we can see them on the night sky. We can similarly hide all as well to restore the view that we had before. Whenever you start a new profile, going through the available actions is generally a great place to learn what you can do in that profile. The last panel shown in the toolbar is the SkyBrowser. This panel gives us access to a whole other amazing piece of software called Worldwide Telescope. The link to their homepage is in the description, and be sure to check them out. When we open the panel, the only action we can now do is Add Browser. When pressing this, OpenSpace will freeze for a few seconds as it downloads a catalog of astronomical images. When that is finished, we see 2 new objects appearing in the view of OpenSpace. The first one is a new panel with image data that we can move around. The second is a rectangle with a crosshair that shows where on the sky the first panel is pointing. When we left-click and drag in the panel, the target moves around and we can see that stars show up correctly. We can zoom in and out in that panel using the mouse wheel, and the target changes accordingly. In the SkyBrowser panel, we currently see a list of all images that Worldwide Telescope provides, which can be a bit overwhelming. So we want to filter it by selecting the drop-down menu at the top and choose Images Within View. Now, the list only shows images that are present in the current view. We pick one of the images, and the target zooms in to show us that specific image in its correct context. If we zoom out again, we can select the second image in the vicinity of the first. At the bottom of the panel, we see controls for the individual images that allow us to move the target back to an image, reorder images, change the opacity, and control many other features. Particularly interesting are the settings where you can change the border radius if you prefer a circular image shape, or the ability to directly enter right ascension and declination coordinates if you're interested in images taken at a specific location. Coming back to the drop-down menu at the top, another option here is sky surveys, which are images that are covering the entire sky rather than being of individual objects. Lastly, I'd be remiss to point out the info button next to most of the images that provide a short description of the image, including a link to the webpage that contains even more information. Every profile determines separately which buttons are visible in this toolbar at the bottom. Regardless of the profile, however, we can access all of the possible panels through the Windows menu entry at the top. From here, we can open or close any panel. So we continue our tour through the user interface in this menu by opening the Settings panel. At first glance, this panel looks very similar to the Scene panel we looked at in the last tutorial. The Settings panel also gives you access to properties, but the ones that affect OpenSpace as a whole. We can find the controls for the dashboard in here, so if we don't want to see the frame rate, for example, we can turn that off right here. Or maybe we want to change the font size of the location on the globe to 24 points instead. It is fairly rare that you'll need to go in here to change something, but there are a lot of useful settings in here to customize OpenSpace to your preferences. For example, we can look at the navigation handler, which handles all kinds of camera interactions. The jump to fate duration, for example, refers to how long the transition takes when you teleport to another object. If we teleport ourselves to Mars, you can see that it takes exactly 1 second to get there. Let's say we want this to take 3 seconds instead. Now if we teleport back to Earth, its teleport takes a lot longer. Another setting worth mentioning here is under Orbital Navigator, which is the navigation that we've been using this whole time with the mouse. Here we find all settings relating to the friction of the camera. The 3 friction modes that we can toggle through the buttons in the menu bar, or F, Shift F, or Control F, are here as well. We can also control how strong the friction on the camera should be. Under Idle Behavior, you can toggle Should Trigger When Idle, which will automatically start a slow rotation whenever we don't move the camera for a while. Lastly in here, we find the mouse sensitivity to control how far we have to move the mouse to make a certain amount of motion with the camera. These are just few of the controls that are available in the settings, and it's worth checking them out. If we open the next panel, the Mission panel, right now we can see that the default profile does not include any mission information. So I'll just make sure that there is some mission information available. To get to this, you would load one of the other profiles that comes with OpenSpace, for example ESA's Rosetta mission to 67P Churyumov-Gerasimenko, from which this data comes from. The mission panel contains general information about the specific mission, including in this case the mission patch. To the left, we see that this mission is split into multiple different phases, for example during which time the mission was in hibernation. Clicking on the phase shows information about that specific phase. Phases are defined by the fact that they cover a range of time, in this case from June 8, 2011 to January 20, 2014. The other information contained in missions are orange markers on the timeline. These are called milestones, which occur at a specific moment in time. This milestone, for example, on August 6, 2014, is the time when Rosetta arrived at the comet. Clicking it shows a short video sequence of the images taken by the spacecraft too. Before we can have a look at the next panel, the flight control, we need to talk about a different feature first. Up here in the Help menu, we can find an option to open GUI in browser. If we select that, a browser window will now open up on your window that will show the user interface separately. If we try to control the camera from this browser, however, nothing happens. And this is where the flight control panel comes in. If we open that panel in the browser and enable the flight control, we now have an active blue border from which we can control the camera in OpenSpace. While this might not be very useful on the same computer as we're doing here, we can also get this user interface on a different computer, for example a tablet. The OpenSpace documentation page contains more information on how to configure these kinds of setups. The next panel we have a look at is called the Keybinds. As the name implies, this panel shows us the keyboard layout with all of the actions that we can trigger by pressing keys on the keyboard. For example, if we click on the F key, we can see that it toggles the rotation friction. Shift and F correctly shows us that it toggles the zoom friction. But we can use this panel to discover new keyboard shortcuts as well. F1, for example, toggles the main GUI. So if I press F1, the user interface disappears. Very useful for making clean screenshots. Shift F1, by the way, hides the remaining user interface elements like the dashboard and other pieces of text. Speaking of taking screenshots, pressing F12 will do exactly that. These screenshots will be placed in your OpenSpace user screenshots folder in a folder with the date when you started OpenSpace. Pressing Shift F1 and F1 again restores everything back to how it was before. Now we look at the Night Sky panel that is designed to guide the view when looking up from the Earth. To start, we pick any location on Earth and zoom straight in. When we are on ground level, we pan up the camera to look up at the sky. We now pick the location during the day, so we need to change the time in OpenSpace to make the sun set below the horizon. We use the arrow keys to speed up the in-game time within OpenSpace. And here we are at nighttime, and we press space to pause the time. Since we looked at the sun as it was setting, we are already looking towards the inner solar system and can see trails of the other planets. The Night Sky panel starts with a markings group that shows different ways of navigating the night sky. One of these markers we can use, for example, is the meridian. A meridian is a line connecting the North Pole to the South Pole. The most famous meridian is the prime meridian, which is going straight through the Greenwich Observatory outside of London. Here, the meridian on which we find ourselves is shown as an outwards projection above us. Another interesting marking is the band of the ecliptic. The ecliptic is the path on the celestial sphere that the sun moves through. If we enable the band of the ecliptic, we can see where the sun is located at different times throughout the year. If we jump, for example, to the 1st of August, we can see that the beginning of the August month is located just above the horizon. And if we now move forward one day at a time by holding the Shift key and pressing the button above the current day number, we see how the path of the ecliptic moves from our standpoint on Earth throughout the year. The time that we just advanced by is actually called a solar day, since it is the amount of time until which the sun is back in the same position relative to Earth. We can also see how jumping forward by a sidereal day looks like. The sidereal day is the amount of time until all other stars, except for the sun, are back in their same position. These 2 days have a difference of about 4 minutes and are due to the fact that the Earth moves along its trail while it is rotating, so it has to catch up the remaining time. There are many things to discover in this panel, but the last thing for now we find in the sun section. If we choose today's date and add trail, a trail for the sun's movement throughout the day is added, so we can see the trajectory that the sun is moving through as the day progresses. If we use the location view part of the panel and jump to North Pole, we can see how that exact same trail would look like from the North Pole. As we pick the day during northern summer, the trail is almost parallel to the horizon. So as the day progresses, the sun is staying at roughly the same elevation in the sky, causing a 24-hour sunshine. The next panel in the list is the Getting Started tour. It is an interactive tutorial designed to guide you through the camera movements, how to change properties, and how to focus on other objects in the universe. Since we have gone through this together in the first tutorial video, we don't have to do this here again, and we can skip this panel. The last, and in terms of a beginner's tutorial also least panel, is the script log. As we will discuss in a later, more advanced tutorial, almost everything in OpenSpace is scriptable. Everything that the user interface is doing is just executing scripts in a language called Lua. The script log shows us all of the scripts that have been executed in this session. This panel is going to be extremely useful when you start making your own profiles, actions, assets, or other content, but for now we leave this for a later tutorial. So this gets us to the end of the user interface. We went through all of the different panels that exist in the software and showed how they work. We learned how to make session recordings, find places on Earth, add new panels to the user interface, trigger various pre-canned actions, explore the worldwide telescope, change system-wide settings, look at mission information, control OpenSpace from an external browser, find keyboard shortcuts, look at the night sky, we skipped the Getting Started tour, and we looked at the script log. Many of these panels give you access to different tools, but how you use them to explore the universe or give presentations to others is up to you. The next few tutorials will delve deeper into different categories of content, and we will use the panels to explore the existing datasets as examples of what OpenSpace can show. Thanks for watching, and I'll see you next time.